Hi everyone and welcome back to another lab. In today's lab, we will explore the first scenario of practicing variable length subnet masking. So what I will be doing is to give you an introduction about variable length subnet masking. Then we are going to discuss what is the main objective of this lab, and we will follow this by walking you through the topology and then the lab task. Towards the end of that section, I will then walk you through the configuration steps and the lab solution. So, what is variable length subnet masking, or another word, VLSM? It is a technique that is used in IP network design to optimize the allocation of IP addresses by allowing different subnets to have subnet masks of varying lengths depending on the requirements. So, subnetting is the process of dividing a large IP network into smaller subnetworks called subnets. Each subnet is then identified by a unique subnet address and has its own subnet mask. In traditional subnetting, all subnets within a network have the same subnet mask. This is known as fixed length subnet masking, or VLSM. And this subnetting is simple to implement. However, it may lead to inefficient use of IP addresses, especially when subnets requires significantly different number of hosts. So variable length subnet masking allows network administrators or network engineers to use different subnet masks for different subnets within the same network address space. This allows for more efficient allocation of IP addresses, as subnet masks can be tailored to the specific requirements of each subnet. And this is one of the tasks that will help us gain this skill. The variable length subnet masking enables hierarchical addressing, where larger subnets are further divided into smaller subnets, each with its own subnet mask. This hierarchical structure facilitates better management of IP address space. So, the benefit of variable length subnet masking is the efficient utilization of IP address space, as it provides flexibility in designing and scaling networks and allows you and me and administrators to create subnets of different sizes to accommodate varying numbers of hosts or network segments. And this scalability is particularly valuable in large and complex network where address space optimization is critical. And variable length subnet masking facilitate hierarchical addressing scheme, as we discussed earlier, which can simplify routing and reduce the size of routing tables. It also helps administrators to design networks with a granular level of address allocation, which makes it easier to manage IP address assignments and subnet configurations. Finally, variable length subnet masking can help organizations to minimize costs associated with acquiring and managing IP addresses, especially in scenarios where public IP addresses are limited or very expensive. So, how does the VLSM work? So, the first step in implementing variable length subnet masking is to assess the network's requirements, including the number of hosts needed in each subnet and overall topology of the network. Based on the network requirements, the administrator allocates a contiguous block of IP addresses from the appropriate address space. And that is typically using a classful or classless addressing scheme. Then the administrator divides the allocated IP address space into smaller subnets of varying sizes. Each subnet is assigned a unique subnet mask that corresponds to the number of hosts required in that subnet. Once the subnets are created, the administrators then assigns IP addresses to devices within each subnet, ensuring that the addresses are unique and fall within the appropriate subnet range. Then we configure routers to advertise the individual subnets using their respective subnet masks. This allows routers to accurately route traffic to the appropriate destination based on the longest matching prefix in the routing table. So to optimize the routing table size and reduce network overhead, you can use route summarization techniques to aggregate contiguous subnets into summary routes. These techniques help streamline routing, updates, and improves network performance. So the objective of this lab is to practice variable length subnet masking to efficiently allocate IP addresses in a network with multiple subnets, especially when we aim to understand how to subnet a given IP address space into smaller subnets of varying sizes to meet the specific requirements of each subnet. So, through this lab, we will gain hands on experience in subnetting, address allocation, and designing hierarchical network architectures using variable length subnet masking principles. Okay, so what we're going to do next, we are going to talk about the lab topology. And as you can see on the screen, we have a router 1, and switch 1. And switch 1 is connected to PC1, PC2, PC3, all the way to PC12. PC1 and PC2 are part of the engineering department, and they are going to be part of the VLAN 100, whereas PC3, PC4 are part of the human resources department, which is in VLAN 200, PC5, PC6 in the IT department, VLAN 300, and PC7, PC8, we can see them that they are part of the production department, which is in VLAN 400, and PC9, PC10 are part of the finance department, which resides in VLAN 500, and finally we have PC12, PC11 as part of the distribution department, and they are in VLAN 600. Switch 1 is then connected to router 1, and router 1 has a loopback interface 100, which represents Google DNS, which is the 8888 IP address. Okay, so what I want to talk about is the IP address and VLAN tables. And the first table that you will see on the screen is the router IP address table, and it is basically self-explanatory. What you see on the screen here is the device name, which is router 1. We have the interface ID, which are the loopback interface, which is already been assigned IP address 888, and the subnet mask is 32. We also can see the sub interfaces that we would need to configure at some point later. And the IP addresses here are empty because this is one of the tasks that we would have to do to fill up these IP addresses as per requirements. If I then move into the next table, we see that we need to tackle the host IP address table. And again, we would need to complete that at some point when we actually tackling the tasks of the lab. And it is again self-explanatory. The device name, which is PC1 all the way to PC12, the department of which PC is part of, and we have the interface ID, which is part of the PC. We would need to finish and complete the empty cells, where we need to complete the IPv4 address, the subnet mask, the default gateway, and the side annotation. We're going to talk about all of that in as part of the configuration steps and lab solution. And then the third table is the switch VLAN table. So we will need to configure multiple VLANs on switch 1. And what you see on the screen here, switch 1 gig Ethernet 01, which is connected back to the router 1. That is going to be in a trunk mode, and it will allow the following VLANs, which are 100, 200, 300, 400, 500, 600. We have fast Ethernet 01 and 02 will be participate in VLAN 100. Similarly, with fast Ethernet 03 and 04 will be participating in VLAN 200, so on and so forth. So next, let's talk about the lab task. And what you see on the screen here is a list of tasks that we would need to tackle in this lab. And the first task is we would need to build the topology, connect all the devices, and build the lab itself, either virtually or physically. And then once we have done this step, we can then move to step number 2, which is configuring the appropriate host name for each device as per our topology. And then after we've done that, we're going to move into router 1 to create a loopback interface 100 and assign the IP address of 8888/32. Okay, so what we are going to do next, we are going to do some documentation and understand the business requirements. And based on the business requirements, we are going then to do some documentation. For example, creating a table following the attributes of department, network address, broadcast address, maximum number of hosts based on the subnet giving. We would need to allocate the first host and the last host, as well as the CIDR notation. And as you can see on the screen, so we have different requirements for different departments. So we can see the engineering department requires about 100 hosts, whereas the human resources department requires about 6 hosts. The IT department also requires 6 hosts, whereas the production department requires about 55 hosts, and the finance department's 10 hosts, and the distribution department requires 25 hosts. So if we then move down the list of tasks, it says here you must assign address block with the department that has the largest number of hosts and ending with the department with the smallest number of hosts. So to complete this task, we would need to look at the business requirements and look at the department that requires the highest number of hosts first, and then the second highest, and so on and so forth. Okay, so what we are going to do next, we need to make sure that when we assign IP addresses, we must provide the smallest block of IPs per department. And then next, what we need to do, we need to create a table, IPv4 address table that includes the default gateway, the IPv4 address, and the subnet mask for each PC. And we need to follow the requirements as you can see on the screen. So the first requirement is each odd PC number must use the first usable IP address from the given subnet. And each even PC number must use the second available usable IP address from the given subnet. And then each PC must use the last usable IP address from the given subnet as the default gateway. And assign the last usable host address from the given subnet to each sub interface configured on router 1. Next, we are going to create sub interfaces on router 1 using interface gig Ethernet 001 for each department. And we are going to assign the relevant IP address. We are going to enable the interface. We're going to set the description per sub interface, and we are going to set the VLAN ID, etc., etc. We are then going to move to the switch, and we are going to configure the switch port that is connected back to the router as a trunk. And then we are going to create all the VLANs, and we're going to associate the name accordingly. And then we are going to set all the ports that are linked to our computers or PCs with the appropriate VLAN. And then we are going to assign IPv4 address, subnet mask, the default gateway on each computer. And then we are going to verify connectivity between each host with default gateway and the loopback interface of router 1. And once we have done this testing, we then can go ahead and save our configurations. And I believe at this stage, the lab will be completed. Okay, so before I proceed with the next step, you will find in the video description, I included information related to the lab. You will have the lab document that also include the solution, and you will also be able to download the Packet Tracer lab ready to go for you to configure. You will see that I included 2 different Packet Tracer files. One that is the pre-configuration steps, and the other one is the post-configuration steps, which have the full solution. With that being said, it is your chance to pause the video and give it a go yourself. Otherwise, just keep watching. Okay, so I'm going to deviate from the configuration steps by jumping into step 4. And once we have solved this step, I will go back and cover step 1 and step 2 and step 3. So what you see on the screen is a subnet mask calculator, and the first column represents the CIDR notation, and that column represents the number of bits of the IP addresses that are used to represent the network. And CIDR stands for Classless Interdomain Routing Notation, and it is a compact representation used to express IP address ranges and their associated subnet mask. It simplifies the representation of network addresses, and it does that by combining the IP address with the number of leading bits that are used to identify the network portion. Whereas the bits column represents the number of bits that will be counting in binary in the IP address or the mask. Whereas the max network column is used to identify the number of networks that you can have based on the subnet mask. Whereas the maximum host column is the maximum number of hosts that are available for the given subnet. And the subnet mask is the subnet mask expressed in dotted decimal notation, which is consists of 4 octets separated by periods. Each octet represents 8 bits of the 32-bit subnet mask, with values ranging from 0 all the way to 255. In binary form, a subnet mask with all ones in the network portion and all zeros in the host portion represents a network address. So how you can build this table is basically when you build the CIDR notation, which what you need to start the table with, and you can always remember to start with 32 and then go down 1 each time. So 32, 31, 30, 29, 28, 27, all the way to 16. And if you wanted to carry on all the way to 0, you can do so if you wish. Whereas the number of bits, we start with 0 and then we go all the way down. We add 1 each time. 0, 1, 2, 3, 4, 5, etc., all the way to 16. The maximum number of networks, we can always start with 1 and then we double that every time. So 1, 2, and then 4, and then 8, and then 16, 32, 64, 128, and then multiply 128 by 2, it will give you 256. Multiply that, it will give you 512, so on and so forth. The same applies with the host. We start with 0, and then how you can work it out is basically you take the maximum number of networks and then you subtract 2 from it. So we have 4. 4 minus 2 is 2. 8. 8 minus 2 is 6. 16. 16 minus 2 is 14. 32 minus 2 is 30. 64 minus 2 is 62. 128 minus 2 is 126, so on and so forth. Next is the last bit of the table, which is the subnet mask. And to work out the subnet mask is very simple and straightforward. You just need to follow the pattern. And the first one is /32, which is 255.255.255.255. The next one is 255.255.255.254. And how do we get 254 based on this calculation is you get the maximum number of network from the previous record. And the previous record is only 1, so we subtract 1 from 255, that will give us 254. We then move to the next one, which is /30. You can see that it's 252, and the reason why it's 252 is because we are adding 1 plus 2, that would give us 3. 3 minus 255, it will give us 252. And if you follow this pattern all the way, you will see that you'll be able to actually write the subnet mask based on the CIDR notation. That way, once you understand how you can create your own subnet mask calculator, you can then use it as and when you need to. Okay, let's move to the next step. Now that we have discussed how you can understand how to do the calculation, let's actually look at the business requirements or the lab requirements and try to figure out how we can tackle the IP address allocation. So the IP address that we are going to use in this lab is the 192.168.0.0/24. And we are going to start this with the department that requires the highest number of hosts. And since we went through the lab requirements, we know that the engineering department requires the highest number of hosts. and that is 100 hosts. Now, to accommodate 100 hosts, we would need to assign /25. And if I go back to the subnet mask calculator, if I want to accommodate 100 hosts, I would have to choose /25 or this subnet mask so that I can accommodate 100 hosts. And the reason why I'm choosing /25 is because the one above it, which is /26, it will only give you 62 hosts, which is not enough. We will be short of 38 hosts. And the one above it, that will give us 254 hosts, which is way higher than what we actually expecting. So the most suitable subnet that we would need to allocate to this department, it will be /25. So based on that, we will need to use 192.168.0.0, but this time, instead of using /24, we are going to use /25. And the subnet mask that corresponds to this side annotation is 255.255.255.128. So what does that mean in terms of the network address? So the network address will be 192.168.0.0/25, and the first usable IP address will be 192.168.0.1. The second usable IP address will be .2, and so on and so forth. And then the last usable IP address, it will be 192.168.0.126. And the broadcast of this network, it would be 192.168.0.127. And if you wanted to figure out how the last usable IP address is being calculated, is very simple. What you would need to do, you would need to get the maximum number of hosts that are available for this particular subnet, and then you need to add it to the network portion. So in that case, we would need to say 0 plus 126. That will give us 126, and that would be the last usable IP address. In order for you to figure out the broadcast address, is also very simple and straightforward. You just need to figure out the number of available hosts that is associated to the subnet, and then you will need to add 1 to it, and that will give you the broadcast address. So that is the first department. If we then move to the next department, we will find that the production department requires 55 hosts. And this time we will need to start from the following available IP address, which is going to be 192.168.0.128. And that would be the portion of our next IP address. So we would want to accommodate 55 hosts. And in order for us to accommodate 55 hosts, we would need to use 26. The reason being why we need to use 26 is because 26 will give us 62 available hosts, and that can accommodate easily 55 hosts as per requirements. So the network address for that space, it will be 192.168.0.128. And the subnet mask this time is going to be 255.255.255.192. And the first usable IP address is pretty much straightforward, is the next available IP address of the network address, which is going to be 192.168.0.129. And again, the subnet mask will be different this time. You can see that is /26. And then to work out the last usable IP address, we would need to add 62 plus 128, and that will give us 190/26. And that will give us 192.168.0.190. If you then want to work out the broadcast, you can just add 1 to the last usable IP address of that particular network, or you can just simply add 62 plus the network address. So 62 plus 1, that will be 63, plus 128, that will give you 191. So this is the IP segment that will be assigned to the production department. Next, we are going to tackle the distribution department, as it requires 25 hosts. And in order for us to accommodate 25 hosts, we will need to use /27, and that will give us 30 available hosts. We use 25 hosts within that range, and we will have 5 IP address remain where we can use for future growth. And since we are starting from the next available IP address, which is 192.168.0.192, we will use that as the network address, and the subnet mask will be 255.255.255.224. And then the first usable IP address, it will be 192.168.0.193. And then the last usable IP address, if we use the trick that we know, we would need to say 30 plus 192, and that will give you 222. If you wanted to work out the broadcast address, we just need to add 1 to the last usable IP address, or we can add 1 to the available hosts associated to the subnet mask in question, and then we would need to add it to the network address, which is 192. So 192 plus 1, that's 193, plus 30, that will give us 223. And that will be the broadcast address for this network segment. If we then move to the next one, we will see the finance department, and that requires 10 hosts. This time we're going to start with 192.168.0.224. And because we need 10 hosts, we would need to use /28, because /28 will give us 14 available hosts. So the network segment, again, is we're going to start with this address. So 192.168.0.224, and that is /28, which is 255.255.255.240. The first usable IP address is very simple, is 192.168.0.225. That is going to be /28. And then the last usable IP address is basically 14 plus 224, and that will give us 238. And the broadcast address is just adding 1 to the last usable IP address, which is going to be 239. If you wanted to work out otherwise, you can add 14 to 224 plus 1, and that will give us 239. If we then move to the next one, the HR department, it requires 6 hosts, and we know that /29 will give us 6 available hosts. So that actually fits the requirements, and that's the most efficient way of doing it. And since we are going to start with 192.168.0.240, because that's the next available IP address, we would have to start with this one as the network address for the next network segment. And that is going to be 192.168.0.240/29, which is 255.255.255.248. The first usable IP address is the next IP address, which is 241. And then the last usable IP address, we would need to add 6 plus 240, and that would give us 246. The broadcast IP address is going to be 246 plus 1, which is 247. And then finally, we find the IT department, which requires also 6 hosts. So we're going to use the same subnet, which is /29. This time we are going to start from 192.168.0.248. And that is going to be the network address with /29. And the mask is going to be 255.255.255.248. And the first available host will be 192.168.0.249. And then the last usable host, we are going to add 6 to 248, and that will give us 254. And the broadcast in this segment, it will be 192.168.0.255. So the final solution for the IPv4 address table as per department, we have the engineering department. It will have the 192.168.0.0, and we will give it the 25 side annotation. Next, we will see the production department, which is 192.168.0.128, followed by the distribution department, which is 192.168.0.192. Then the finance department will be 192.168.0.224. The HR department will be 192.168.0.240, and then the IT department will be 192.168.0.248. Then what we are going to do, we are going to fill the IPv4 address table for router 1. We see that the first sub-interface is associated to the engineering department, so we are going to give it the appropriate IP address. which is the last usable IP address, if you remember the lab requirements. And the same applies for the second sub interface, which is associated to HR. The third sub interface is associated with IT. The fourth sub interface is associated to production, and so on and so forth. So you can take a screenshot if you want, because we are going to start the configuration step next. And then finally is the IPv4 address table for all hosts. So I'm just going to cover the first couple of departments, and then you can just follow the rest accordingly. So the PC1 and PC2, part of the engineering department, and we are going to assign the first usable IP address, which is 192.168.0.1, and that is going to be /25. And the second PC or PC2 is going to be 192.168.0.2, and the subnet mask is going to be /25 or 255.255.255.128. If we then move to PC3, which is part of HR department, it will have the first usable IP address of that segment, which is going to be 192.168.0.241, and the subnet mask is going to be 255.255.255.248, which is /29 inside a notation. And PC4 are going to assign 192.168.0.242 with the subnet mask of 255.255.255.248. Okay, so what I will show you now is the configuration steps. And the first step is always build the lab either physically or virtually according to the lab topology. So what I'm going to do next is I'm going to log into the CLI of router 1 and switch 1 and start configuring the host name according to the topology. And then we're going to move forward from there. So what I'm going to do, I'm going to log into the CLI of switch 1 and router 1. And then I'm going to go to enable mode, and then from there go to configure terminal, and then here I'm going to say hostname router 1, and I'm going to do the same thing for switch 1. So step number 1, step number 2 are complete. Now we move to step number 3, where we need to create a loopback 100 interface on router 1. So what I'll do, I'll say interface loopback 100, and I'm going to assign the IP address of 8.8.8.8 with 32 subnet mask, which is 255.255.255.255. So the loopback interface is primarily used for internal testing and diagnostics, and also management purposes. So we can use the loopback for monitoring devices, and it is used as the source or destination for routing protocols, as it also provides high availability and redundancy. And the reason being is because loopback interfaces are not tied to a particular physical interface. They can be used as the router ID, for instance, in routing protocols to facilitate seamless failover in redundant router setup. So we have managed to tackle step number 4 and step number 5, as we already completed the IPv4 address tables. And now what we are going to do, we are going to tackle step number 6. And step number 6 is creating the sub interfaces on router 1. So what we are going to do, first, we would need to go to interface gig Ethernet 001 config mode. And from there, we would need to set the description, and we would need to enable the actual interface, because by default is actually shut down. So I would say interface gig Ethernet 0/0/1. And I would say description link to switch 1. And we are going to say no shot. And then the first thing that I'm going to do next, I'm going to configure the engineering department sub interface. So I'm going to say interface, or even better if I arrow up multiple times to get the interface gig command, and then I'll just add dot towards the end of the interface ID, and I would add the VLAN ID, which is 100. I will hit enter, and then in there I'm going to say description, and I'm going to say engineering department, and the IPv4 address is going to be, before we actually do that, we would need to do the encapsulation first. So we need to say encapsulation.1q, and we're going to set the 100 as the VLAN ID. The encapsulation.1q command is used on a sub interface to enable the IEEE.1q trunking encapsulation, and we use this command for enter VLAN routing or supporting a trunk or VLAN segmentation. Hence why this command is quite important and imperative in our setup. So next, what we can do, we can actually configure the IP address on the sub interface. And we're going to say IP address 192.168.0.126. And the subnet mask is going to be 255.255.255.128. We just confirm, we just say no shot, just in case. And then we have completed the engineering department from router 1 perspective. Now let's go to the HR department next. I scroll up to get to that command, interface gig ethernet 001.100, and I can just change it to 200. And we're going to just repeat the same config, and this time instead of using the engineering department, we are going to say the HR department, or human resources. Next, we are going to do the encapsulation.1q command, and we're going to set the VLAN tagging, or the VLAN ID, to 200. And then I'm going to set the IPv4 address 192.168.0.246. And the subnet mask is going to be 255.255.255.248. And we're going to say no shot. Next, we are going to tackle the IT department, which is going to be part of VLAN 300. And again, I'm going to just arrow up until I get to that description command, and I'm going to just replace HR with IT. And then I'm going to also replace the 200 with 300. And then I'm going to configure the IP address, and this time is going to be 192.168.0.254, and the subnet mask is going to be 255.255.255.248. We are going to tackle the production department, and we're going to just replace the 300 with 400, and we're going to configure the description for it. And then the encapsulation next. And then finally is the IP address. It's going to be 192.168.0.190. And the subnet mask is going to be 255.255.255.192. Next, we are going to tackle the finance department. Let's quickly the description for that sub interface. and then set the encapsulation to 500. And then the IP address is 192.168.0.238 with the subnet mask of 255.255.255.240. I'm going to say no shut. And then finally, we are going to tackle the last department, which is the distribution department. And the distribution department resides in VLAN 600. So we're going to create a interface of gig Ethernet 001.600. We're going to do the same thing. We're going to start with changing the description. Let's say distribution department and encapsulation .1q. That is going to be 600. And finally, the IP address is 192.168.0.222, and the subnet mask is 255.255.255.224. Let's say no shut. So at this point, I think we have completed step number 6. And what I will do, I'll just maximize the CLI window, and I'm going to say show IP interface brief. You can see that we have gig Ethernet 001/100 all the way to 600 with the appropriate IPv4 address assignment. We also have loopback 100 with 8888, and you can see the status is up. Next, what we are going to do, we're gonna move to step number 7, where we are going to do some configurations on switch 1. So the first task on configuring switch 1 is to configure the port that is connected to router 1, which is gig Ethernet 01. So I'm going to go to config terminal, and from there I would go to interface gig Ethernet 0/1, and from here I would say the description is going to be link to router 1. I will enforce the switch port mode to trunk. So I'm going to say switch port mode trunk, and also I'm going to allow only the specified VLANs that we have configured on router 1. And to do that, we will need to say switch port trunk allowed VLAN, and then we would need to list the VLANs in question. We're going to say 100, 200, 300, 400, 500, and 600. So if you wanted then to verify that, what you can do is you can issue this command, show interface gig Ethernet /0/1, and you would need to mention switch port towards the end of that command, and that will give you information related to that interface. So you can see the operational mode here is trunk, and the encapsulation is .1q. And the VLAN that is allowed or enabled for that trunk is 100, 200, 300, 400, 500, and 600, as you can see on the screen. There is also another command that I would like to share with you, which is the show interface trunk. And this command displays information about trunk interfaces and their associated VLANs. So I would suggest to use this command when you verify trunk configurations and trying to troubleshoot trunking issues on Cisco switches. So the next step, which is step number 8, is we would need to create all the VLANs on switch 1. And the way we do that is as follow. So we go back to config mode, and from there we just specify the word VLAN, and then we say the VLAN ID. In that case, we'll say 100 for the engineering department, and we're going to name that VLAN accordingly. So we're going to say engineering department, and then you hit enter. Up arrow to go to VLAN 200, and I'll change that from engineering to human resources, and then configure the next VLAN, the IT department next, and then VLAN 400, and that is going to be the production department. Up arrow, set the VLAN to 500, and then set the name to finance department. N, and then we move to VLAN 600, and we are going to set it to distribution department. And now, if you wanted to verify that, what you can say, if you issue show VLAN and hit enter, and let's just maximize this. What you see here is you can see the VLANs that have been configured. We have configured the VLAN 100, 200, all the way to 600, and we have given it the appropriate name. Accordingly, engineering department, human resources, IT, production, etc., etc. At the moment, none of these VLANs are associated with any physical interface. I think this is what we are doing next. But what we can see is the configuration have been implemented accordingly. Next, what I'm going to do, I'm going to jump into step number 9. And what I will be using is a command called interface range to configure 2 or more interfaces. And that will save time and it increases your productivity as well. So I would say interface range and fast Ethernet 0/1, and we want to go from 1 to 2. I would hit enter, and you can see that the prompt this time has changed from just config F to config F range. And in here, we're going to say description. This is going to be engineering department. And we are going to say switch port mode access. And we are going to associate these 2 ports with VLAN 100. So to do that, we would need to say switch port access VLAN 100. Do the same thing for port 3 all the way to 4. So we're going to say switch port mode access, and we're going to say switch port access VLAN 200. And then we're going to say 5, 6. And that is going to be the IT department. And switch port mode access next. And then we need to assign the VLAN accordingly. That is going to be 300. Next, we're going to tackle port 7 and 8. Change the description from IT to production. Port access. And the VLAN associated with these 2 ports are going to be 400. Next, we're going to configure number 9 as well as number 10. And that is going to be the finance department. and then switch port mode access, switch port access VLAN 500. Finally is port 11 and 12, and there's going to be the distribution department. And that is going to be switch port mode access, and finally the VLAN is 600. So we would need to do some verification, and to do that we would need to say show VLAN brief. And you can see that this time we have assigned each interface with the relevant VLAN. So Fast Ethernet 01 and Fast Ethernet 02 are part of VLAN 100, and these are for the engineering department. Fast Ethernet 03, 04 are part of the human resources department, which is VLAN 200, so on and so forth. So next, what we are going to do, we are going to actually configure each computer accordingly. So I'm going to minimize that, and then I'm going to start going to each computer, and here PC1 is going to be configured with 192.168.0.1, and the subnet mask is going to be 128 towards the end, which is 255.255.255.128. And the default gateway is going to be 192.168.0.126. So that has been done. Let's move into the next one, PC2. And PC2 will have 192.168.0.2, and the mask is going to end with 128, and the default gateway 192.168.0.126. Next, we're going to tackle PC3, and we are going to say 192.168.0.241, and the subnet mask is going to be 255.255.255.248. And the default gateway is going to be 192.168.0.246. Next, if we go to PC4, and then we're going to say 192.168.0.242, and that the subnet mask is going to be 248, and the default gateway is going to be 246. We then close this, go back to the CLI, minimize that. We go to PC5. PC5 will have 192.168.0.249, and the subnet mask is going to be 248, and the default gateway 192.168.0.254. Okay, next we move to PC number 6. We go to desktop and then ipconfig, and we would say the IP address is 192.168.0.250, and the subnet mask is going to be 255.255.255.248, and then the default gateway is going to be 192.168.0.254. So once we've done that, we go to the CLI mode, and then we'll move to PC7, And PC7 will have 192.168.0.129, and the subnet mask is going to be 192. The default gateway is going to be 192.168.0.190. We close this, we go to the CLI and we minimize. We do the same thing for PC8. So we say 192.168.0.130. And the subnet mask is 255.255.255.192. And the default gateway is 192.168.0.190. We close this, we go to the CLI and minimize this. Next, we go to PC9. Again, we do the same thing. So the IP address is going to be 192.168.0.225. Subnet mask is going to be 255.255.255.240. The default gateway is going to be 192.168.0.238. Once we've done that, we close this, we go to the CLI and we minimize this. Go to PC10. Again, we do the same thing. And PC10 is going to be 192.168.0.226. Subnet mask is 255.255.255.240. And then the default gateway is 192.168.0.238. Close this, we go to the CLI, and then the final department, PC11, and we configure the IP address of 192.168.0.193, and the subnet mask is going to be 224 or 255.255.255.224, and the default gateway is going to be 192.168.0.222. We close this one and we go to the CLI, and then finally we configure the last PC, and the IP address is going to be 192.168.0.194. The 255.255.255.224 subnet mask, and the default gateway is going to be 192.168.0.222. Close this one and go to the CLI. So next, what we are going to do, we are going to tackle step number 11, where we are going to check our connectivity all the way to the default gateway as well as the loopback interface 100. So we're gonna start with PC1, and first of all, we need to issue the IP config. And here you can see that the IPv4 address assigned to this PC is 192.168.0.1, and the default gateway is 192.168.0.126. So I'm going to do ping 192.168.0.126. You can see that we get successful ping, and let's ping 8.8.8.8. We also get successful ping. Minimize that. I'm going to do the same for PC3. And the default gateway is this IP address. So I'm going to just copy it and I'm going to say ping IP address. And you can see that we have managed to get connectivity successfully. Next test is the 888.8. We also get successful ping. Let's move to PC5. And let's ping the default gateway first. We get also successful ping. Let's ping 8.8.8.8. We also get successful ping. So let's move to PC7 and copy the default gateway as well. Ping that one. We get successful reply. We ping 8.8.8.8. We also get successful reply. Let's move into PC9. And in here, we can ping the default gateway, which was 192.168.0.238. We get successful ping as well. And finally, let's ping 8.8.8.8. And we get successful ping. Next, let's tackle PC11. Then ping the default gateway first. And we get successful ping. Let's ping 8.8.8.8. We also get successful ping. Now, the final test, but I'm not going to cover pretty much every department. I'll just cover a couple of departments. Let's see if PC1 is able to ping PC2. So we know that PC1 has an IP address of 192.168.0.1. So PC2 will be .2. So it's going to be 192.168.0.2. And we also get successful ping. I will also check connectivity between PC11 and PC12. So the PC11 has this IP address, and PC12 will be one available IP address, which is 194. And if I ping this IP, I can see that I'm able to ping PC2. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. Stay curious, stay inspired, and until next time, peace.